Hello, boys and girls. How you doing? We are on Chapter 5, Lesson 5, Prime and Composite Numbers. Okay? Prime and composite numbers. So those are two types of numbers, aren't they? All right? Prime numbers are special. Prime numbers only have two factors. So in the factory, right? There are only two numbers that can make a prime number in the factory. All right, so I'm just going to give you a little prime number, which one comes to mind? 5. 5 is a prime number. So the only numbers in the factory are 1 and 5 that can make a product of 5. Okay, prime numbers only have two factors. Some people say the factors are 1 and the number itself. All right. So look at this big chunk I pulled out for you here. Your directions say tell whether the number is prime or composite. Now composite numbers are anything that's not prime. So that's kind of pleasant, isn't it? Boys and girls, we are going to use our divisibility rules for a lot of these. Okay? That is going to be your best friend when it comes to prime and composite numbers. All right, guys? So let's think now. We know the rule for 2, 3. We know the rule for 6. Oh, I skipped the rule for 5. Of course you know the rule for 5. 2, 3, 5, 6, and 9. Okay? All right, so let's jump in here with number 4. It's the number 63. Well, I'm just going to test out a divisibility rule right away. I'm going to go 6 plus 3 equals 9. What's the divisibility rule for 3? Do you remember? If you add the digits of the number 6 plus 3, and that sum is divisible by 3, then the number itself, 63, is divisible by 3. Let's think about that one more time. I use the divisibility rule for 3, which says that, I'm going to make this plus sign better, plus, okay. If you add the digits, 6 and 3, okay, it's still on, okay. If you add 6 plus 3, and that sum is divisible by 3, which 9 is divisible by 3, 3, 6, 9, then the number itself, 63, is divisible by 3. So is 63 a prime number? No, because it's divisible by 3. So 3 times something is going to equal 63. So if 63 is divisible by 3, 3 is a factor of 63, right? So it cannot be a prime number then. It has to be composite. Okay? Those divisibility rules are super helpful when you're figuring out prime and composite numbers. All right, let's look at number 5. The number is 75. All right, what's the rule I'm thinking of? I'm looking at that little 5 right there in the ones place. Every number that's divisible by 5 ends in 5 or 0. 75 ends in 5. So that means that 5 times something, we don't even care right now, is 75. So 75 has 5 as a factor. So 75, you are not prime either. You're composite. Okay? All right, on we go to number 6. Here's the number 31. So let's think about our divisibility rules. It doesn't end in 5 or 0. It doesn't end in 0, 2, 4, 6, 8, which would make it divisible by 2. So 2 would be a factor, so that doesn't work. Let's try adding the digits. 3 plus 1 equals 4. Is 4 divisible by 3? No, it is not divisible by 3, is it? All right, so let's think about, okay, so it's not divisible by 2 or 3. 2 or 3 or 5 or 6. Okay, so let's check 4. We don't know 4. So let's just count by 4s. Okay, 4. Well, you know what? I already know that 5 times 4 is 20. So I'm going to start with 20. 20, 24, 28, 32. Oh, we just hit past. Okay, so 4 is not a factor. All right, let's think about 7. I'm going to count by 7s and see if I get to 31. 7, 14, 21, 28, 35. Whoop, nope. All right, how about by 8s? 8, 16, 24, 32. Nope. And then we know it's not divisible by 9 because we know the divisibility rule for 9. If you add the digits and the numbers divisible by 9, so no. So guess what 31 is, friends? It is a prime number. And you know what? You're going to get to the point where you just remember some of the prime numbers, like 31. Of course, you know 2, 3, 5, 7, 11, 13. You know those. But 31, that's a good one to just remember. All right, let's check number 7 really quick here. 77. Boys and girls, who knows their 11 times tables? That's like some of the best times tables ever. 2 times 11 is 22, right? 5 times 11 is 55. Guess what 7 times 11 is? 77. So that means that 7 and 11 are factors of 77, which makes 77 what kind of number, boys and girls? Prime or composite? Composite. Okay. All right. On to number 8, 59. 59. All right, let's try some divisibility rules. I'm going to go back to this list. It's not divisible by 2 because it doesn't have 0, 2, 4, 6, 8 in the ones place. All right, let's check 3. 5 plus 9 equals 9, 10, 11, 12, 13, 14, right? Is 14 divisible by 3? 3, 6, 9, 12, 15. Nope. Is 14 divisible by 9? Because it's the same divisibility rule. 9, 18. No. So it's not 9. And it's not 3. And since it's not 2 or 3, it's not 6 either. Remember the rule for 6? If it's divisible by 2 and 3, it's divisible by 6. Well, it's not divisible by 2 or 3. All right, so I'm going to use for 59 some break apart strategies here. If I did 40 plus 19 is 59, right? Because now I'm checking my 4s. I'm seeing if it's divisible by 4. I know that 40 is divisible by 4, but is 19 divisible by 4? Absolutely not. So 4, you are also out. We know it's not divisible by 5. Now let's try 7. 7 times 5 is 35. So what I'm going to do, draw a little line there. 35, 42, 49. I'm seeing if I'm counting by sevens to see if I get to 59. 56. Oh, I'm not going to get to 59, am I? Because I'm only 3 away. All right, 7, you are out. How about 8? 8 times 5 is 40. So I'm going to start at, I'm going to do it over here. I'm going to start at 40, count by 8s, because I want to see if it's divisible by 8. Because if it's divisible by 8, 8 would be a factor, and it would be composite. 40, 48, 56, nope, because 56, that's only 3 away. All right, so guess what, friends? Prime 59 is another prime number. All right, we have one more, number 9, 87. So I look for the ones place. It's not divisible by 2 because it's an odd number in the ones place. It's not divisible by 5 because it doesn't end in 0 or 5. So let's do the adding of the digits. 8 plus 7. Okay, I add the digits 8, 9, 10, 11, 12, 13, 14, 15. And what do I ask myself about 15? Is 15 divisible by 3? 3, 6, 9, 12, 15. It sure is. If 15 is divisible by 3, then say it with me, 87 is divisible by 3. Is that not the best divisibility rule ever? So since we know 87 can be divided by 3, that means that 3 times something is 87. So 3 is a factor of 87. So 87, you are composite. Okay? Wonderful work, you guys. Those divisibility rules are the best. And don't forget that little break apart strategy that we used when we were thinking about 59. Okay? All right, let's keep going. The number 1. You know what, boys and girls? This even tricks 5th graders. Okay? They always are like, oh, what's 1? What? A lot of kids say that the number 1 is prime. But prime numbers have 2 factors. How many factors does 1 have? Well, let's see. It has 1 factor. 1. Okay, so we say that the number 1 is neither prime nor composite. 1 is just a little special star, isn't it? Number 1, you're a star. You are neither prime nor composite. You're just the number 1. Okay? So don't let that one trick you. Let's keep going. All right, we are on number 4 in the spiral review. All right, this is from chapter 4, lesson 3. A store clerk has 45 shirts to pack in boxes. Each box holds 6 shirts. What is the fewest boxes the clerk will need to pack all the shirts? All right, so you know exactly what Mrs. Olvey's going to do. Reread. What does the store clerk have? She has 45 shirts. Okay, that's a lot of shirts. So she's packing them in boxes. Each box holds 6 shirts. So each box will hold 6. What is the fewest of these boxes the clerk will need to pack all the shirts? Okay, so what are we thinking here, boys and girls? It's a classic division problem, isn't it? If you put your hands out wide, you say, I have 45 shirts, and then you're going to put them equally by sets of 6 into boxes. It's like a sharing problem, right? All right, so 45 divided by 6. Now, that's not a basic fact, is it? Do you guys know your 6s pretty well? I bet you know 6 times 6, right? So 45 divided by 6. 6 times 6 is 36. What's 6 times 7? 6 times 7 is 42. Should we rewrite this like long division? Because you're looking at it and you're like, wait, this looks like a basic fact. We're going to rewrite it in long division just so that we see what's going on here. I like to label the dividend shirts because that helps me remember that every single number down here that I write, those are all shirts. Okay, so we were just talking about basic facts here. 6 times 6 is 36. 6 times 7. 6 times 7 is 42. Okay, so we can separate the shirts into 7 boxes. So is that the answer? Look, there's 7 right there. I hope you're all yelling at your computer. No, no, Mrs. Olvey, it's not the answer. That's right, because guess what this number is at the bottom? That's also shirts. Remember, if that's shirts, then that's shirts. The dividend and the remainder are in the same group. They're shirts. Okay? So if we have 3 shirts left, the store clerk has to pack those 3 shirts. Right, guys? So 7 boxes will hold 42 shirts, but we need another box. It's not going to be a full box, but you still have to put the 3 leftover shirts in a box. You need 8 boxes. Okay? Whenever you have problems like this, guys, really put yourself in the story and think, what is that? Label, what's that? And what does my remainder mean? I have 3 shirts laying on the floor in the store. Put them in a box. All right, you guys, have a great night.